Same underlying model. One answers and stops. The other reads the record, cross-checks the interactions, updates the care plan, and messages the patient, all without being asked again. That gap is what this episode is about. Stack lessons. Episode 17. Answer incoming. By the end of this video, you'll be able to explain the difference between generative AI and agentic AI, and name the Amazon Web Services pieces that make agents run, Bedrock Agents, AgentCore, and the Model Context Protocol. This is some of the newest material on the exam, so it's worth getting crisp on the definitions. In episode 9, we covered Amazon Bedrock as Amazon Web Services managed foundation model platform with that HIPAA-eligible boundary that made it usable for Beacon Labs at all. We walked through its building blocks, knowledge bases, guardrails, prompt management, and one we flagged but didn't open up, agents. And across the customization ladder, from prompt engineering through fine-tuning, everything we've built so far produces output for a human to review. Today we cross a line. This is about systems that don't just answer, they act. 5 terms will carry this whole episode, so let's pin them down first. An AI agent is a foundation model that plans, calls tools, watches what comes back, and loops until it hits a goal. Amazon Bedrock AgentCore is Amazon Web Services' current platform for building and running those agents securely at scale. The Model Context Protocol is an open standard for how agents plug into external tools. Multi-agent collaboration is when a supervisor agent farms subtasks out to specialist agents and stitches the answers together. And Strands Agents is Amazon Web Services' open source kit, where the model itself drives the orchestration. Amazon Web Services draws the line in one sentence. Generative AI produces content you review. Agentic AI takes actions to complete a goal. Let's put those side by side. Line the two up side by side. Generative AI is reactive. You give it a prompt, it gives you content, and it hands control straight back to you. One turn, and the output is a document. Agentic AI is proactive. You give it a goal, it plans the steps, and it keeps looping on its own until the task is actually done. The output isn't a document. It's a completed task in the real world. And notice how the risk changes with it. Generative AI's risk is informational. A wrong answer you can catch on review. Agentic AI's risk is operational. A wrong action, which may already be done before you see it. That shift from informational to operational risk is easier to feel with a concrete picture. A generative model is a brilliant consultant. You describe your trip, and it writes you a detailed, thoughtful travel plan, then hands it back across the desk. An agent is a travel agent with a phone. It reads the same goal, calls the airline's API, books the hotel, checks your calendar for conflicts, and emails you the confirmation. Here's the thing worth noticing. The difference isn't intelligence. Both are equally smart. The difference is the phone. Tool use is the single capability that turns answering into acting. So, how does an agent actually work under the hood? At the heart of every agent is one simple cycle. It starts with the goal and the current context. The model reasons, it plans and picks the next step. Then it acts, it calls a tool. Then it observes what came back. And here's the crucial part. That observation feeds right back into the next round of reasoning. The agent loops, reason, act, observe, reason again, until the goal is done. People sometimes call this the react pattern, reason plus act. This loop is exactly why agents can adapt to what a tool returns, and exactly why each pass can trigger a real-world side effect. That definition on screen is the foundation. The plan, the tool call, the observation, and the loop are not abstract. They map onto 5 concrete moving parts. Let's name them. Pull an agent apart and you find 5 parts. The foundation model is the brain. It does the reasoning. The instructions carry the goal and the rules it must follow. The tools are its hands, the things it can actually invoke in the world. Memory is its notebook, holding what happened earlier so it isn't starting fresh each turn. And orchestration is the loop that ties them together. Hold on to the caption at the bottom, because it matters. A long, detailed prompt with no tools is still just generative AI. Without the hands in the loop, you don't have an agent. So we have the 5 parts and the loop that drives them. The next question is how Amazon Web Services actually runs one of these in production, and the answer comes in 2 flavors. We've now defined what an agent is and isn't: model, instructions, tools, memory, wrapped in a reason act loop. The next question is how Amazon Web Services actually runs one of these in production. That's where Bedrock Agents and AgentCore come in. Back in episode 9, we flagged Bedrock Agents as the block that lets the model do things. Here's how the original version worked. Launched in 2023, it was Amazon Web Services' first managed agentic service. You pick a foundation model, write the agent's instructions, and then define what it can do through action groups. An action group is the key mechanism. It pairs an OpenAPI schema, which describes an operation, with a Lambda function that actually runs it. That's how an API becomes a callable tool. At runtime, the agent loops through the React cycle we just saw, and it exposes a trace, a record of the rationale, the action, and the observation at every single step, which is gold for auditing. Now, one lifecycle detail you genuinely need to know. The Bedrock documentation now opens with this notice: Amazon Bedrock Agents, now called Bedrock Agents Classic, is no longer open to new customers. For similar capabilities, Amazon Web Services points you to Amazon Bedrock AgentCore. Existing customers keep using it as normal. So Classic is still fair game on the exam as the original reference, action groups, Lambda, the orchestration loop. But it's in maintenance mode, and AgentCore is the platform for anything new. So what is AgentCore? Here's the official definition. It's an agentic platform for building, deploying, and operating effective agents securely at scale using any framework and any foundation model with no infrastructure to manage. Sit with 2 phrases in there: any framework, any model. You're not locked to one way of building. And securely at scale, security is baked into the pitch, not bolted on. That framing matters, and we'll come back to it hard at the end of the episode. AgentCore isn't one thing, it's a modular suite. You don't need to memorize every box, but a few are in their place. Runtime is the serverless environment your agent executes in. Memory holds both short-term and long-term context, and it can be shared across agents. Gateway exposes your tools using that open standard we're about to cover. Then 2 you'll want to remember for the security domain: identity, which answers who is this agent, and policy, which enforces real-time guardrails on what it's allowed to do. And observability records every action for the audit trail. Underneath it all, the caption is the headline. It works with any framework and any model: Strands, Crew AI, LangGraph, and more. Since both are in scope, here's a fast way to tell them apart in a scenario. If the question describes a fully managed agent built from action groups, with Lambda functions running the actions and an orchestration trace, that's Bedrock Agents Classic, and remember, it's closed to new customers. But if the scenario mentions any framework, any model, tools connected through gateway, and enterprise identity and policy controls, that's AgentCore, the current platform. The queue is essentially action groups and Lambda point at Classic, framework agnostic and gateway point at AgentCore. Now the piece that Amazon Web Services Gateway is built on, the Model Context Protocol. We touched on it briefly in episode 2, and here's the core idea. Before MCP existed, every AI application that needed to call an external tool had to build its own custom integration. One connector for Salesforce, a different one for your database, another for your internal API, a drawer full of proprietary cables. MCP replaces all of that with a single open standard. It specifies exactly how an AI application announces its intent to use a tool, how the tool responds, and how results flow back. Build your tool server once to the MCP spec, and any compliant agent can use it. No custom glue code required. Here's the problem MCP solves, drawn out. On the left is the world before it. Every agent needs custom integration code for every tool it talks to. 2 agents and 2 tools already means 4 bespoke connections, and it explodes as you add more. That's the tangle you're looking at. On the right, MCP sits in the middle as one common protocol. Every agent speaks it, every tool speaks it, and now any agent can reach any tool without writing glue for each pair. Build once, connect everywhere. That's why adoption has been so fast. An MCP server exposes exactly 3 things, and the exam may ask you to sort a capability into the right one. First, tools. These are executable functions the model calls, and they have side effects. They actually do something. The model controls these. Second, resources. Read-only contextual data the application surfaces. No side effects, just information the app makes available. Third, prompts. Reusable templates the user picks. The clean way to remember it: tools do, resources inform, prompts template. It all runs on JSON Remote Procedure Call version 2.0. And it's an open standard, not Amazon Web Services specific, not Anthropic specific. Let me underline this because it's a clean thing to get wrong. MCP was created by Anthropic, but it's been adopted right across the industry. OpenAI, Google DeepMind, and nearly every major AI tooling vendor. Amazon Web Services implements it through Gateway. Amazon Web Services does not own it. So if a scenario frames MCP as an Amazon Web Services only or Anthropic only technology, that framing is the wrong mental model. It's a shared open protocol, and that's precisely the point of it. So how does Amazon Web Services turn that abstract protocol into something you can deploy? That's Gateway. It takes your existing APIs, Lambda functions, and third-party services and converts them into MCP-compatible tools. An agent connects once to the gateway and gets back a single combined tool list from every backend behind it. And crucially, Gateway enforces security on both sides: inbound OAuth authorization to check who's calling, and outbound IAM authentication when it reaches the real system. If you've used an API gateway for human clients, this is the same pattern: routing, auth, and policy, but for AI agent clients instead. Halfway point, let's consolidate. An agent is a model plus tools plus a reason-act loop. Amazon Web Services gives you 2 platforms for running one: Bedrock Agents Classic, the original, and AgentCore, the current. MCP is the open standard that connects agents to tools, and Gateway is Amazon Web Services managed MCP endpoint. Now the next question: what do you do when a single agent isn't enough for the job? Sometimes one agent hits a wall. The task is too broad, needs too many kinds of expertise, or would overflow a single context window. That's where multi-agent collaboration comes in. Amazon Web Services describes it this way: it enables multiple agents to collaboratively plan and solve complex tasks, breaking work down, assigning pieces to specialists, and working in parallel. Instead of one agent trying to be everything, you assemble a team. The topology is clean. At the top sits one supervisor agent. It receives the request, triages it, and later synthesizes the results. Below it are the collaborators, the specialists. The supervisor breaks the request apart and delegates a piece to each one. And here's the detail that trips people up. On the caption at the bottom, each collaborator is a full agent. It has its own tools, its own knowledge base, its own instructions. These are not stripped-down helpers. They are complete agents, coordinated by the supervisor. One quick build note worth knowing: the supervisor has to be saved before you can attach collaborators to it. That topology has an intuitive real-world twin. Picture a hospital emergency department, which is a fitting image for Beacon Labs. The triage nurse is the supervisor agent. A patient comes in, and the nurse routes them. Chest pain goes to the cardiologist, the scan goes to the radiologist, the pharmacist checks the drug interactions. Each specialist has their own instruments and their own expertise, and the nurse pulls their findings together into a plan. But it also surfaces the uncomfortable question that will define the rest of this episode. When an autonomous chain of decisions ends up affecting a patient, who is accountable for it? That accountability question is real, and it shapes how Amazon Web Services built its own orchestration kit to answer it. Strands Agents is Amazon Web Services' open-source agent kit. It runs on AgentCore runtime, and it works with any model. What makes it distinctive is its philosophy. It's model-driven. Instead of you hand-coding the workflow, Strands trusts the foundation model itself to plan the steps and chain the tool calls. The model-driven approach also means every decision the agent makes is driven by the same foundation model you can inspect and audit, which matters a lot when the hospital analogy question is, who is accountable? And this isn't a demo. Strands is already in production inside Amazon Q Developer, the coding assistant we covered back in episode 10, as well as Amazon Web Services Glue and Kiro. Here's the conceptual contrast the exam might probe. In the model-driven approach, Strands, the model itself, decides the sequence of steps. You write very little orchestration code, and it stays flexible for open-ended adaptive tasks. In the graph-driven approach, LangGraph is the usual example. You define an explicit state machine yourself. That's more boilerplate and more determinism, and it shines when you need strict, predictable branching logic. So which do you reach for? If the task is open-ended and you want to trust the model to figure out the path, model-driven. If you need to control the exact flow with hard branching rules, graph-driven. Either is universally better. It's a fit to the task. The hospital analogy raised a question about accountability, and that question points directly at a new category of architectural risk, one that sits underneath whichever orchestration style you choose. Here's the four-part framework that makes those questions concrete. Here's a way to feel the stakes. Giving an agent write access to your production systems is like handing a brand new hire in their first week unsupervised keys to the patient database, the billing system, and the external communications platform all at once. You would never do that with a person. You scope their permissions, you add oversight, and you build trust incrementally. The same logic has to apply to an agent. And for Beacon Labs, there's a sharp edge here. When an agent autonomously reads, updates, and transmits protected health information, it triggers the same HIPAA obligations as any human touching that data. The catch is that HIPAA frameworks were written for human actors. The agent isn't a covered employee, but it acts exactly like one. Before you deploy an agent, 4 scenarios. First, identity. Who is this agent? On Amazon Web Services, AgentCore Identity manages that, handling the agent's own OAuth and IAM credentials. Second, permissions. Is it scoped to least privilege on its tool calls? That's policy in AgentCore, enforcing real-time controls on what it may do. Third, oversight. Is a human in the loop, approving each step, or on the loop, watching and able to intervene. Those are your human checkpoints. And fourth, auditability. Can you explain every single action it took? That's AgentCore observability, keeping the trail. The bottom line pulls it together. Scope permissions plus an audit trail are the two core mitigations Amazon Web Services itself points to. Amazon Web Services sums up the mitigation in one sentence, and it maps cleanly onto that diagram. Agentic AI, it says, operates with greater autonomy within the permissions you set and maintains an activity trail you can audit. Two ideas doing all the work there. The permissions you set, that's least privilege, enforced by policy. And the activity trail you can audit, that's observability. Autonomy is fine, as long as it's fenced by permission and recorded for review. That framing carries extra weight for Beacon Labs. Covered entity data under a compromised agent isn't just a reliability problem, it's a compliance event, which is exactly why this connects to the governance material ahead. That sentence is also the thread that connects forward. Least privilege and audit trails contain the risk we just named, but only if the agent's IAM permissions are scoped tightly enough to make them meaningful. An overprivileged agent with access to protected health information isn't just a technical problem for Beacon Labs, it's a covered entity risk, the kind that shows up in a compliance audit. When we reach the security, compliance, and governance material, this is exactly the scenario those controls are designed to prevent. Before we close on the definition side, let's lock in the decision reflex that will help you separate these four Bedrock capabilities in a scenario question. If the task is to access current documents without retraining, that's retrieval, Bedrock knowledge bases. If it's to take an action through an API, that's an agent, Bedrock AgentCore. If it's to block harmful content, that's guardrails. And if it's to compare model outputs, that's model evaluation. The trigger word that separates the agent from the rest is action. When the scenario asks the system to do something, not just answer something, reach for the agent. Let's gather what to carry forward. Agentic AI is a foundation model that plans, calls tools, and loops until a goal is done. The step from answering to acting. Bedrock Agents Classic is the original platform, now closed to new customers. AgentCore is the current framework-agnostic one. MCP is the open standard connecting agents to tools with 3 primitives, tools, resources, and prompts, and Gateway is Amazon Web Services MCP endpoint. Multi-agent collaboration is a supervisor delegating to specialist collaborators, and Strands is Amazon Web Services model-driven kit. If you remember nothing else, remember these two. The definition of agentic AI, and that autonomous action escalates risk, which you govern with identity, policy, oversight, and observability. Now let's see how well all of that landed with a quick 5-question quiz. Question 1. Hospital team wants a system that, when a lab result arrives, autonomously reads the patient record, updates the care plan and the electronic health record, and sends a follow-up message with no one re-prompting it between steps. Which best describes it? A generative AI application because it produces the message text. B, an agentic AI system because it plans and executes multi-step actions toward a goal using tools. C, a retrieval augmented generation pipeline because it reads the record first. Or D, a prompt chaining workflow because several model calls run in sequence. Lock in your answer before I give it away. The right call here is B. The system doesn't just generate content, it takes real actions across tools, reading, updating, and transmitting, and it loops toward a goal on its own. That reason act with tool execution pattern is exactly what makes something agentic rather than merely generative. Question 2. An enterprise wants its AI agents to connect to Salesforce, Slack, and Jira without writing custom integration code for each agent and tool pairing, using an open standard, so the same tools work with agents from any vendor. Which technology directly addresses this? A, Bedrock guardrails to filter tool inputs and outputs. B, Bedrock knowledge, bases to index the 3 systems. C, SageMaker Jumpstart to deploy a pre-built integration model. Or D, the Model Context Protocol, a standardized way for agents to connect to external tools. Pause here if you want more time. It has to be D, and here's why. MCP is the open standard that lets any compatible agent talk to any compatible tool without bespoke per-pair code. That's the build once, connect everywhere idea. On Amazon Web Services specifically, AgentCore Gateway is the piece that implements it. Question 3. A team designing a new agent reads that Amazon Bedrock Agents is no longer open to new customers. They need the current Amazon Web Services platform that supports any framework, any model, MCP-connected tools, and agent-level identity and permission controls. Which service? A. Amazon Bedrock Agents Classic. B. Amazon Q Business. C. Amazon Bedrock AgentCore. Or D. Amazon SageMaker Jumpstart. Got your pick? Let's see. The answer is C. AgentCore is the current framework-agnostic platform with gateway for MCP tools plus identity and policy. Classic is the one that's closed to new customers, and neither Q Business nor Jumpstart is an agent orchestration platform at all. Question 4. A clinical company is about to give an autonomous agent write access to systems holding protected health information. A reviewer asks which two mitigations most directly reduce the agentic risk. Which pair fits best? A. Scoped least privilege permissions on tool calls, plus an audible trail of every action. B. A larger context window and a higher temperature. C. More few-shot examples and a longer system prompt. Or D. A faster model and prompt caching to lower latency. Run the decision rule from earlier before you answer. The right call here is A. Amazon Web Services frames the two core mitigations as operating within the permissions you set and keeping an activity trail you can audit. That's least privilege policy and observability. Context window, temperature, and caching are real settings, but none of them touches the risk of an agent taking a bad autonomous action. Question 5, and this one's a callback to an earlier episode. Beacon Labs Assistant answers questions over clinical trial protocol documents that update weekly, and the answers must reflect the latest version without retraining the model. Which capability makes that possible? A. Fine-tuning the model each week on the updated protocols. B. Retrieval augmented generation, fetching current documents at query time. C. Continued pre-training on the protocol corpus. Or D. Raising temperature to increase variety. Think about which one avoids touching the weights. If you said B, well done. Retrieval augmented generation pulls fresh documents at query time, so a weekly update shows up instantly with no retraining. Fine-tuning and continued pre-training both change the model's weights and would mean rerunning on every update, and temperature has nothing to do with keeping documents current. This is exactly why Beacon Labs chose RAG for that assistant, and why an agent, when it needs current docs, leans on the same retrieval pattern. That's the end of Agentic AI, Bedrock Agents, and the Model Context Protocol. Subscribing keeps these free and pushes them to more people prepping like you, so if it helped, please do. Let me know in the comments what landed and what didn't. If you've got a cert you want next, the comments are open. And if the style or the speed could be better, I want your honest take. See you in the next lesson.